Good afternoon, and thank you for joining SPEC Innovation's special announcement webinar. My name is Elizabeth Steiner, and I'll be your moderator. Today, we're going to be showing you the latest features in Innoslate 4.5 and a sneak preview of our newest product, Sopatra, a digital assistant for your standard operating procedures. Before we get started, let's go over some quick housekeeping. Today's webinar will be 1 hour long. Please feel free to stay afterwards for the question and answer portion. During the presentation, feel free to send us your questions so we have them ready for the Q&A. Alternatively, you can ask us questions in our LinkedIn user group or through Twitter using the handle @Innoslate after the webinar. The webinar is being recorded and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. Dr. Dam is the president and founder of SPEC Innovations. He has been involved with research, experiments, operation analysis, software development, systems engineering, and training for more than 40 years. He has also received an expert systems engineering professional certification from INCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions to the LinkedIn user group or send him an email to steven.dam@specinnovations.com. I'll go ahead and give the controls over to Dr. Dam and we can get started.
Thanks, Elizabeth. So let's just jump in. For those who don't know us, we've been in business since 1993. We got into the software business about 2010. We released our first product in 2012, which was Innoslate. And so this was a kind of a thing we found we needed as systems engineers, and because we were a little frustrated with the tools that were out there at the time. So one of our big things is about the future, pushing forward through the new technologies, adding capabilities all the time. So 4.5 is our latest release. It was released yesterday to both our public AWS cloud and also to the Gov version of that, the US government version of that cloud. So they're available. We will be releasing the enterprise version 2 weeks from yesterday, and so that's when if you are using the enterprise version, you'll be able to get that one and download it and be able to install it into your system. So there's lots of features in the tool, and that's why we think it's going to take us a while just get through the slides and some demo, but we want to leave plenty of time for questions. So if we do run past the 1 hour, we're going to stick around until we can answer all your questions. Okay, so let's get into it. Lots of changes. Hopefully most of you are familiar with all the features we have already, so this will be just like, wow, okay, new stuff. Okay, so we just added branching and forking. This was actually a feature we had in version 3.9 that wasn't really working that well. It was in beta. It kept a beta flag on it the whole time because there were issues. So we think we've responded to those issues and have everything we need to do a very good job now with branching and forking. This should enhance our ability to do product line development as well as other things in terms of management of your data. Another new feature is the program management dashboard. This was something that we came up with after quite a bit of analysis that we did for some government customers, and so this was kind of a way to bring together the program management aspects of the tool and add to those. So we've added a new calendar. There's a to-do list on this dashboard. There's hot links to the Kanban Boards and the Gantt Charts, and a number of other things. So it's a work in progress. We're going to continue to upgrade and update this as we go, but this hopefully will be something to help you as a program manager in terms of working with the information and tracking your projects and doing more with that. Again, we've been using it that way for quite a number of years, but this will enhance that capability significantly. Another thing that was one of the big focuses actually of this version of the tool was the simulator updates. The old simulator was actually still running under the 3.9 framework, And so we'd been wanting to redo it for this framework that we changed to. But that was the big change between 3 and 4, was we changed our JavaScript framework to Vue.js. And so it was important for us to get the simulator finally up to date and to that, and that gave us a whole bunch of new tools, new looks and views. We are still giving you access to the old simulator though too. It has some pluses, and again, there's pluses and minuses to everything, and so we're trying to give you the best of both worlds. And so you can use either one of them, and they work them in combination as you need to. So a lot of different things there. One of the new things in this simulator is much more configurable views of like graphs and things like that, so that you can do a lot more with that. Also, you can export it and store it as a .sim file. So this means you can replay these things. So if you're running simulations as part of your testing, and you want to then capture that as a test result, you can now do that very easily within the tool. Another feature was also update was the action diagram. So a number of things in the action diagram. One of the most exciting things to me personally was this idea that we wanted to be able to do decomposition of input-output elements. That had been something on my list for quite some time, and so we added that. We also added a value and a typing to it so that you can use it to represent software messages or software variables. Or messages in a system service, and it can be used in the simulator in a variety of ways. So this gives you that as well. So that decomposition and the ability to use it as a variable and treat it like a variable. That all been one of my big goals with it. So here we go. We finally got there. Diagram updates. So okay, lots of different things. We added a new class diagram generator. It lets you import your Java code and automatically create the class diagram for you. Now, this is actually a well-abstracted class diagram. It's meant to be something that someone at a higher level of abstraction would want to look at and could understand and work with. It doesn't have all the details. So very often, when I first was teaching myself Java back in 2000, I had a tool called JBuilder, and did a great job of creating a class diagram, but it was so complex because it had all the details that were going on in the code. That's not the purpose of a class diagram. That's supposed to be an abstraction. And so that's what we did with it. So you can see the things it supports, and again, nested classes as well. So it's actually a very fully functional, capable generator for us. This is also part of our development trying to work the round tripping with going from requirements to development, and then taking the results of the development and be able to view it and understand it and analyze it to see if it met the requirements properly. Another thing we've done is a number of these views that came in for the program management views were actually chart updates. And so there's a significant amount of updates to charts you'll see. And calendar chart was one of the charts that was added to that view. So that's another way to get at it, is through the charts view. Kanban board again is another one of those. This lets you capture your tasks. And by the way, these are now using a new subclass called task, and that gives us a number of things like due dates and things like that have been added to that as attributes. It's a subclass of action, so you can still use it in an action diagram. And in fact, the action diagram update does now let you select any subclasses of the action as well. So this is where you can bring in now your test cases or now your tasks as you want to see them and work with them in that view too. So again, all this is interoperable between the other views, so you're not losing anything, you're just gaining a lot. Another thing that's kind of new is the Gantt chart view. So I think that's kind of something you'll like and see. Yes, the calendar, it works properly. You get good dates out of the calendar. You'll like that a lot. Again, it's dependent on the tasks. It also has the ability to track your dependencies better. So we actually have a very nice suite of that. We did not get rid of the timeline diagram. If you love the timeline diagram, which I do, we did not get rid of that. This is in addition to that timeline diagram. So it's not a replacement. Another new feature, it's something people have been asking for some time, is this hierarchical reports, the ability to create a report. Now this is done from entity view, and you can now take and it will create a report for you of all the decomposition of that entity. So you start usually with a parent and then it'll work your way all the way through the process. So you get capturing all that information and now putting it at one place. This is something that a lot of people have asked for. We've thought it was something needed for quite some time. We finally got to it. Okay, another one, equations. So we now have the ability to add an equation attribute type. So we do still have the equation class, which is used for system help, but you can add a type now to any class, attribute type to any class with an equation in it. And this way, if you're using a lot of scientific equations, you can see and view what it would look like. And it is based on LaTeX, which is nice because the LaTeX gets put in the description field. And then you can view what this looks like in this attribute type. And I'll show you an example of that here in the demo part. I'm actually very excited about this. The one thing that was disappointing to me was I found out that even though Word on the PC does a very nice job of translating LaTeX, Word on the Macintosh does not. So a little disappointing there, but I've got enough PCs around me if I need to get something put into a paper that I can put there. Hopefully the Mac will catch up with that eventually, that Microsoft will deem themselves available to go ahead and add that capability to Microsoft Word. Okay, that's kind of a quick fire hydrant of many of the features. There's actually more. When you go to the website and go to the Help Center, there are release notes up, and I highly recommend looking through the release notes for all the details. But let's go see it in the tool because, frankly, slides are boring, right? We all agree with that. Okay, so here's the, again, main feature. One of the main features here was the action diagram update. So there's quite a bit of work done on this. A lot of it behind the scenes, things you wouldn't notice, but things like this, where you want to click on that line, and I want to make that line look a little prettier. You can now move that line. That line, it's something that wasn't available before. Also notice it's following the shape better. You'll see the line goes directly to it. It's not going to a point outside of it. So again, a couple of little things like that are important. So we want to see an example of decomposition. I have this error report, and I have error 1 and error 2. It's decomposed by. So if I want to go down to this next level, and I open its decomposition diagram, there's that IO. Now all of a sudden, when I click on it, there's this little button that shows up that says Decompose Parent IO. So all you do is click that, and there now are the two objects you're looking for. So now you can use these at the next level of decomposition. This is what was always meant by peeling the onion. We should be decomposing not only the actions, but also the input outputs at each level. So as you go down, you're getting more and more fidelity of information. You still can, of course, don't have to do that. So don't worry about, gosh, will it work the other way? Yes, it'll still work the other way. Let me cancel that. Okay, so a couple of things like that. So another thing here, of course, was we have the ability to show the new simulators. So here's the new simulator. It looks different. I mean, if you look at the panel here on the side, you can see it's visibly very different looking. But the features are still here. You have the ability to add things, so you have different charts and things like that. As you add the charts, let's see, I don't have a cost chart. It'll actually ask you to select, well, what do you want as cost over time? Total, and maybe my perform normal ops might be something I would do if I had cost roll-ups there. So again, one of the things that right now is it does not roll up the information. So if this is like a parent and all the cost is happening below it, it doesn't roll that up there. So that's something we're probably looking at in the future. Close that. I think I've got them here for examples. You still have the classic mode. So if you want to switch to classic mode, just click this and it'll convert over back to the classic mode. And there you see it with the old icons and all the same things the way we saw it. This is a bit faster, you will see, because it's not doing as much in terms of resources, in terms of the actual computer resources that are required. Let's go back. Go back again here. I think there's probably a quick way to do what I did, probably hit a back button a little bit better. But let's go here again. And so you'll see here an example. And one of the things that happens in it, you'll see a spinner here on the Gantt chart. One of the things that slows things down on the Gantt chart a lot is the rendering. And so as you're doing and rendering things here, you will find that is slowing things down. So again, depends how you want to use it and what you want to do with it. You can see again, it looks very nice. It's very pretty. As I speed it up, and again, if it starts getting too fast, that Gantt chart will get a spinner on it. And if you get too far ahead, it'll stay there until you finish the actual total simulation. But you can see now here, I've got an example of the total costs and contingency costs. And I can colorize the lines, so I can select that and have different colors now for the lines. And there's just a lot more you can do in terms of selection, making it look nice. Also, all the reports are going to show up here in each one of the items. Let me speed this up because, as we remember, this is California wildfire season. This is trying to model. So there we go. I'll catch up here in a minute. So you can see it's going through its part. Yeah, by the way, these panels are all now resizable. So you can adjust the size of those as you need to. Much more flexibility. And any reports and things are here, downloads at the top here. So the variety of different report options, depending on where you are and what you're doing. Very nice. It just looks prettier, for one thing. And some people like this, some people won't. You have options. It's what you want to see, and you hide lines and do all kinds of things with it. So just explore and kind of play with it and see. Again, exporting the results will put it to that sim file, so I can make it so I can store that in as an artifact as well and track it that way. Let's see what else here. Again, you can see that flexibility of that. And of course, the console now has a console report, which again is something very nice to have, something we've been wanting for some time. I think people were just copying and pasting before, so now at least we can put it out more effectively. So again, that's the action diagram simulator changes. Those are the main significant ones here. Let me show you the equation, because I just was playing with that. Example of that. So here's a couple of different equations in LaTeX. Most of you are familiar with E equals MC squared, but the actual equation is this. It's E equals M0 C square over the square root of 1 minus V squared over C squared. Well, that's because this M0 is the rest mass, whereas the M in the classic equation everybody's familiar with is called the relativistic mass. And that's that combination of M0 and this square root down below. So again, very nice, clean, easy to use. You just simply, if you want to see it the other way, I just would copy this. I'm going to paste it in this field, and there it is. So again, very easy to see, very easy to work with. It's fairly easy language to learn if you're not familiar with LaTeX. It's very simple. It's easy to Google and get lots of information on how to do it. I don't know it very well myself, so I was playing around with it this morning, was able to do this. So in a matter of a few minutes. So again, it's something, hopefully something you really enjoy. I know I'm really liking this already. I always wanted to get away from that parametric diagram in SysML. And this gives me an option of seeing real equations. As a physicist, that's what I want to see. Okay, so that's those. Let me jump over to another project to talk about the program management dashboard. So this is actually a project we're working on ourselves right now for a lunar rover for the Icebreaker Challenge, the NASA Icebreaker Challenge. So we're working up our own lunar rover design for that. So the dashboard is set up this way. You can, forward to new months and take a look at your upcoming events that you have identified. And again, go back to today if I want to, tracking those kinds of things. Here's my upcoming dates here on this panel, so I can see what's there. And if I go down below, I've got examples of a hierarchy chart and an example of a lunar a bar chart for the board progress. So this is all about the Kanban boards here, or this is my to-do list. Again, these are hyperlinked, so I can go directly to that item. Another new feature is we have the ability to show attributes and labels now on the hierarchy chart. And so this is kind of cool. And also you have the ability to roll up. So if I wanted to roll up, I would click and hit a roll up. Now, I don't know how you roll up dates very well, but I think it does do it. So I'm not sure that means a lot to you in this case. But anyway, it's the kind of thing you can do and work with as you need to. So again, there's some pretty neat new features that are in the tool. So let's see. What else did I want to show you with this? Let's go back to the management dashboard. So now if I want to get to my other boards, my Kanban board, my chart here, my Gantt chart, so I just select Kanban boards, and that brings me to this view. And so I come over and here's my to-do list, here's my SOW I'm tracking. And so these are different tasks within the SOW. If you click on one, you can see all the information that's been added to it. Got a signee has been put in there, finish date, a due date, estimated date of completion. These were all attributes added to task to this new subclass. And if you're wondering, always take a look over here and some of the labels that we have associated with it to tie up with these boards and things like that. And you can explore the relationships that are here. Dependencies are also now a new, that's a new item as well. New class of information is called dependency. Similar to a conduit, it connects things together. So it's I believe it's a subclass of connection. Let's see, what else do I want to do here? Let's go back to my PM dashboard. A second. And Gantt chart. So again, I have some Gantt chart examples here, things we're doing with that. So here's the new Gantt chart. Looks very nice, very similar to what you see in Microsoft Project. A little better and a little prettier, I think. A little nicer looking, but than it's in Project. But you can see how it works. You can see the dates fields up here look very good. Again, we're not showing milestones. We're not showing the milestone diagram like is on the timeline diagram. I think that timeline diagram still is something that has utility and some value. So we're going to continue with it, working with that, seeing how we enhance that as well. And all the reports and things you might need here are here as well. Okay, so what else do I want to show you here? Trying to think if I got all the biggies. I think I did. Okay. Yeah. So again, adjust these as you need to. So I know you're going to have lots of questions about this, so that's okay. We're going to have time time for questions afterwards, so I'm going to jump though now to the new tool, Sopatra. So let me do that. Okay, Sopatra is a new tool. It came out of some work we were doing for NASA on STTR, that they wanted a digital assistant. And one of the big problem areas that they were having that they needed digital assistance for was how to develop better standard operating procedures. This is a big problem in many industries, particularly the airline industry lives off these standard operating procedures. This is what your pilot does when an emergency happens. They run through this checklist, this set of standard operating procedures that they go through to try to figure out what's the problem and how to resolve that problem. So obviously this has some real world impacts, real world effect on all of us who travel. And in many other industries too. Of course, nuclear power plants have the same thing. Actually, any oil plant, oil refineries, oil work in the field, everybody has, in these kinds of business, has a standard operating procedure. So let's give you a little bit of background and talk a little bit how Sopatra works, give you a little demonstration of it, and talk about the next steps where we're going from here. So a little bit of the background. Again, standard operating procedures are something you're probably very familiar with. The what must be accomplished, when it needs to be done, who's responsible for each step, how each step is performed, what functions are performed in that step, and how to confirm it. So these are all things that need to be in each and every standard operating procedure. So again, procedures define human-machine action, human automation, human-human interaction. Again, it's the human part of this is very important. And so those operator interfaces and operator actions are very critical. And those take time, and that's something that was kind of key out of this research that we were adapting and productizing in this tool. The research work that we're doing is with our partner at George Mason University, the Center for Air Transportation Systems Research. This is the result of many years, decades of research that they've been doing in this area. So again, operator tasks to complete are complex. If you start looking at something as simple as you think, doing alleviating a cardiac arrest situation, you have all these things, and probably the most important part of it is that there are indicators or cues that tell you when you should do something, okay? And oftentimes that requires the operator to have something in what we call LTM, long-term memory. That's problematic, because anytime you have something where you're dependent on the operator to remember something, we're not really good at that. Unless you used something recently, or have done it many times, so it's just rote, then you would have to try to remember, and that takes time, and sometimes that time is critical, particularly if you're trying to save somebody from a heart attack. So these are the things, and so it's a real red line to us as to when the long-term memory is required to do things. This also is something that we have added in the tool automatically in Sopatra, is the ability to add these human actions, the see, hear, and decides, that's what we call them, and the remembers. And so these things can be added to with the tool from this statement, from the standard operating procedure automatically. So that was one of the things we wanted to implement in the tool. Again, some of the problems with SOPs, they're missing steps. Very often that's because the people who are developing these may be experts in the field, and they're used to knowing what to do and when not to do, and they sometimes skip steps, right? When you're writing it down, you sort of say, well, I don't even think that's important. Well, yeah, it is for the people who don't do it every day. The what must be done is specified, but not the when. You know, how quickly does something need to be done? Because if you only have a certain amount of time, that's it. By the way, these are if you want to look up these things on the side here, the TK 1951, that's a flight, and you take a look at these different flights and you see the problems that occurred with them, and these are examples of those having occurred. The information is required to perform the next step is not available. Again, I got to dig into long-term memory and figure out how to make that work. Race conditions, where you've got information not being available in a timely manner. In other words, I need a time machine to make this work properly. And then procedures not being completed in time. Yeah, that's a big one. In fact, that's a really big one. And you can imagine, if you don't complete the procedure in time, usually something bad happens, and sometimes that can be loss of life, as it happened with the Egyptian air example that he's showing here. And procedures difficult to learn due to the user interface cues. Again, it's a similar problem of not knowing where to go to do something. Poor procedural training, that happens again often as a result of many of these other things. And of course, no procedure for the scenario. If you come up with something that just is kind of an unknown, you really are in trouble. And so that's a big problem. And then procedures across systems are not compatible, because invariably different groups have their own procedures, right? The air traffic controllers have their procedures, the airline pilots have their procedures. Do they come together and adjudicate those procedures? No. And of course, that happens with all these different airlines, right? They all have their own set of procedures too, and how to react to things. So it's quite a challenge, let alone the variation of the aircraft and things like that as well. So many things with that. So anyway, so we think that modeling simulation can help us identify some of those SOP problems early. That's the whole goal of this. So part of it, we wanted to supply simple model-based systems engineering techniques to this in simulation, so we can determine where there are problems. So particularly getting a detailed model of these perception, cognition, motor tasks that would have to be performed to complete that SOP. And this is an example that's being shown here of an engine out above maximum altitude for an airliner. So again, one of the nice things working with George Mason is they have this long history of working with the airlines and other groups and trying to understand these procedures. So the objective for Sopatra was designed to make these improvements, add these best practices from the development work that is done by George Mason, and make it so it's as easy as possible for people to use. So Sopatra particularly uses NLP, natural language processing, to interact with the model-based environment, to interact with particularly the textual-based information. So usually an SOP is written in, and to be able to convert that into models. And so we're looking at more and more applications of that in the future, but that's the main thing right now. Also, what this does is provide configuration management and revision management for massive models. As your models get bigger and more complex, it lets you do that. Also giving us the executability, both with discrete event and Monte Carlo. Actually, we did not get the Monterey Phoenix algorithms in there. I'm sorry I didn't catch that. Monterey Phoenix is a different beast. Anyway, so really the key was that Sopatra is designed to be a digital system to take that written, textual-based SOP and convert it into a LML action diagram, and then you'd be able to execute it using the built-in simulators within Innoslate. So again, the need is pretty clear. There's lots of applications out there for this, non-NASA. Again, our customer is NASA, so but they're excited that this is supporting other areas as well. NASA loves to have spin-offs go everywhere. And of course, part of our approach here, we're looking at a whole variety of different ways of automating the text input, see if we can't bring in voice recognition, mixed reality. So we've done some investigating in those two areas. Didn't get a lot progress done in phase 1 here. We're hoping to do more in the phase 2. And then, of course, be able to simulate and analyze the standard operating procedures. I think we've made quite a bit of headway in that one. The main thing is these ideas of MOP. You need some kind of measures of performance, right? So some kind of MOPs. And so that we came, obviously time is the critical factor. And so looking at that factor, these were the ones that George Mason came up with, which was the allowable operational time window. That's the time before something bad happens. So it was from when I start the procedure to when I can finish it. That's my time. That's my operational window. And I've got to get something done before that, hopefully correct the problem before I crash the airplane. And then, of course, the time of the procedure itself. So how long does that procedure take? Okay, and so the difference between those two variables is the procedure buffer time. How much time do I have that gives me a margin? As you can imagine, different people, different things are going to take different times. Different people are going to take different time to execute the procedure. So again, you have to look at that variability, and these are distributions. AOTW and TOP are distributions, and so that means PBT is also a distribution. And so looking at those different types of distributions, you can see it. If you happen to go below zero, if the tail of that distribution is going below zero, that means that a certain percentage of the time there's a probability of failure to complete. Okay, and you may decide that a certain amount of that is okay, depending on what the situation is and what the impacts are. You know, sometimes there's only so much you can do, so much you can do with the windows that are available. So again, these are things that are looked at, and this gives you quite a bit of idea of what your risk is as well. This was our project schedule that we were working to, and again, we've actually exceeded what the original goal of this STTR was, which was to get a prototype done by the end of 13 months. We actually showed the prototype to the customer back in February and productized the tool and are releasing it next week for version 1. Now, obviously, it's a version 1. There's lots more to do, and you'll see that as you go. So how does Sopatra work? So again, we start with that original SOP, formatted it properly, and we, again, like anything else, if you had multiple steps within a single line, then that's going to cause confusions. That's what would be considered bad practice. Much like with requirements, if you have a compound requirement, that's considered bad practice. So again, there's actually a guide we're developing to give it to people to show how to format the SOP well. We also have some supporting documents that help make that conversion, and particularly the acronym list is helpful if you want to substitute out so people know when somebody says like pilot flying, okay, they often use PF, but they might use both in the same thing. So again, those acronyms help us make sure we're doing the same thing. We recognize the commonality between them. Input devices, output devices, similarly, so we can identify what those are. They can be put on their own branch of the action diagram, so that's helpful. And of course, a time distribution database, and that timing thing is going to be very important, and I'm going to hit that a little bit more later. So what we do is take that information, we convert it, and we create the functional model. Then, of course, you can analyze that model, simulate it, and of course, Sopatra's been tailored to provide the specific outputs that we're looking for: AOTW, TOP, PBT, all those kinds of factors, all those metrics are shown now as an output of the Monte Carlo simulation. And then, of course, ultimately, we're going to generate the SOP and put it out in a text-based form, because that's the way people will still execute them for quite some time. So we recognize that reality, and in fact, there's a standard format that NASA would like to see. So that's going to, again, be something we do as we follow on with the development of Sopatra. It's not in version 1, but we're going to be doing that soon. Formatted SOP, here's an example of one. Again, making sure the actor starts it off. So the pilot flying or the air traffic control tells me who the actor is. So that's the asset in Innoslate parlance. And so that defines our swim lanes. And of course, we actually can, with Sopatra, select a set of swim lanes you put together. So this is really kind of cool. And then of course, then we want to put in the action that's happening, and then any results for clues. And again, cues from the output displays, environments, input devices, operator responses, all those things. So as we're reading that information and trying to glean that information out of it, and then put it together in a form that can easily the model can be created. Some supporting documents. Again, here's some of the supporting documents, the acronym list, the input devices, and the output devices as well. Other supported format. Now, this is the time distributions. Now, time distributions are something that are very important in this, because again, the people time can vary significantly. And this is a table that's showing you an example of how much time it can take. And these values are in seconds, by the way. So it's 3 to 17 seconds with a kind of middle point of 7 seconds. So a triangular distribution is used in this a lot, because in fact, that's kind of the best estimate of what you can do in many of these things. There isn't enough data points to create some other kind of normal distribution or things like that. If you've got those data points, great, but otherwise you usually can make a good estimate too. I tell people, if they're doing estimating at the beginning of a project, for example, how long a task will take, come up with well, here's my best case, here's my worst case, and here's what I think it's going to be. And so you use those 3 points, and then you can use that in the Monte Carlo to get a feeling for those distributions as well, that overall time it'll take and my risk. And so again, that's a similar kind of concept here. It's what this provides us. And notice they are different for different situations, where the cues are available or not, whether there's long-term memory involved, the frequency of the action, all these things. So there's lots of information that gets captured with this as well. Again, we were going to provide this for you, information as part of the Sopatra package. That is actually a database that is available and provided as part of the set of documentation that goes with Sopatra. So importing, and of course that's a simple Excel file which you can edit and adjust yourself to, by the way. So the importing, we have a special importer for this purpose. So we bring the information in. There's an SOP import that comes up first, and then you can bring up the other ones as well. And there's a download for it. So if you've uploaded something and you're not sure what you uploaded, download it, take a look at it, and see, and take a look at it, work with it. Again, the resulting action diagram, a couple options. One, you can have it just flat, okay? Or you can have it so it does decomposition. So this is an example of taking this big flat piece here and then seeing the higher level abstraction of it, and then a decomposition of that first element here to the right. So that's what these different pictures mean. Again, we're trying to simplify this for the user base we're looking at. Part of the reason we create Sopatra as a different label from Innoslate is we thought that many of the users of the SOP developers would just be overwhelmed by all the features that are in Innoslate. So we want to give them something simple and easy to work with as to get started, and you'll see that difference. By the way, Sopatra and Innoslate interoperate together, so you don't have to worry about that either. So if you're the system engineer on the project, and you have then your operators come in and do that development and working with the modeling and learning how to do that kind of part of it, then you can take any of their results and bring it into Innoslate and use it completely for that purpose as well. So again, the Monte Carlo outputs, and then this gives you some examples of that, what that looks like. If you're used to our Monte Carlo, you'll see it's similar, but these particular graphs do not get created in the normal Innoslate version. So that's stuff to look at. So you can see here, this has a pretty epic fail rate of 82%. So obviously that needs to be a lot of work on this one, or maybe it's just that the timings that were put into this aren't exactly correct yet. So again, you've got to look at the data. You can't just assume that that the model is going to be correct by itself, right? Okay, this does require real intelligence as well as artificial intelligence. As I mentioned, Innoslate and Sopatra can be bundled together, so feel free to use that. This is a little bit more of how that works together. Kind of slide, and good. That's the last of the slides, so we can actually show it to you. So that's what I really want to get. Okay, so I have Sopatra up here. Let's see if it's still awake. So this is a sample problem we've uploaded. If I go to the analyzer here, import analyzer, I can bring in a files from Innoslate, so I can again import my .inos, my .xmls, and bring them into it and work with it that way. In this one, I can add a new one. If I want to click that, it would add a new process. Not do that. Let me pick one of the existing ones. So here's 3 different existing ones. So this one's already here. So let's do that takeoff one. So this is a couple of the things you can check. The use default branch templates. So this lets you pick that and then split the action diagram into parent and child upon completion. Okay, that's the thing about creating the hierarchy for you automatically. That's my preference. Again, I like abstraction. I don't like to get overwhelmed by one big model because I find that just makes it difficult to understand well. We can bring in either a docx or a .txt file as this, and you'd bring that in. And once you have it in, you can run Sopatra. It'll actually let you execute it right there, then and there. You don't have to load up any of these others, but again, it's helpful to bring those in. And again, we have a time distribution. That's an Excel spreadsheet or a .csv. It can be either format be brought in. Again, you can remove it if you like, and then start over. Input devices, again, that same docx or txt. Output display similarly, and similarly for the acronym list. So again, just very easy to bring those up and work with them. Now, probably some of you are going to say, well, gosh, I'd really like to see what this file looks like. So let's just download it. Go to my desktop. And it must have already been there. Okay, but let's look at it again. Let's open it up. And so here's what the procedure looks like in text. So it's pretty complex. You see a lot of acronyms. I mean, but there is step one, each step, and these are pretty sequential. I mean, they're not. There's no parallels. There's some parallelism in it. There is some whiles and things like that can be dealt with, for example, as parallels. And so you can see it's pretty significant. 77 steps, a fair amount of work to do what this particular procedure is. This is actually a real procedure. This isn't something we made up. This is something that they have on the takeoff of airlines. So this is something likely would be happening like every trip, right? The pilot would be familiar with this, very familiar with this particular procedure. It doesn't mean they're allowed to skip steps, right? Okay, so that's what that looks like. So if I then come over to Innoslate and see the actual diagram itself, so this is the resulting diagram, and you can see in here I've got those decompositions. Now these are actually AOTWs, so this is the available time windows, and so that we have those specific what those are, each case, and they were estimated for Friday. These were actually coming from data that were available. If there's time distributions available for it, it'll tell you, by the way. And it is looking at these parameters over here, the type. So you get to choose what type it is, and then it'll in the frequency and Q. And for AOTWs, the frequency and Q aren't relevant. It's because it's the available operational time window. So it's real time. So now if I go down below to that first stage, you can see this decomposition. Now again, this was choosing the template we have for the swim lanes or the asset lines. Again, these are assets, right? You click on them, that's an asset in Innoslate. Okay. And again, this is where it's important to have consistency in the operator and what they're looking at, operator long-term memory. We hadn't identified anything with that specifically, but we might find some of these as you're doing the analysis are long-term memories. There's also something called working memory. This is where you get a piece of information, you have to keep it in your memory while you do other steps, and then you actually use that piece of information. That's hard for a lot of us too. So it is challenging. And there's a second operator here as well. So they again have the lines for the operator, long-term memory and working memory as well being available. Again, as I click into any one of these things, you can see the different ways you can identify it. You can, by the way, if you have multiples, you can click multiples, and there is apply group distributions duration. So if you want to change a bunch of these at once, you can do that as well. That's a nice little feature. I hope to get that back into Innoslate at some point too, be able to change those time distributions quickly. Anyway, to execute it, you can do discrete event. Actually, let me go up above. Actually, I'll go back. Wait a minute, do one above it. Parent. Here we go. Discrete event. A little more complex. There we go. Now again, remember this has all that capability to change it. Let's go to light mode. There you go. A little easier to see, I think, for you. Now this is cooler, but this is better just to see. Again, you can adjust these as you need to, these windows, and do what you want with them. So, oh, that time, yeah, I can make them bigger. Again, they have a minimum size. So again, I can make them bigger, but I can't make them smaller than the minimum size. Okay, let's just run this. You see the action going. You can see there's a lot of steps here. And so it's going to take time to build the Gantt chart up. But in general, the Gantt chart is really used as a debugger for the Monte Carlo here. But that's how it's really being used. Notice, by the way, the type shows up here as well, so you can see what the types are. Just a lot of nice little features in terms of the this Gantt chart, this new Gantt charts. They're actually quite pretty. Also notice the colors changed. We did color code it so you know you're in Sopatra, not Innoslate. Okay, you can see how that works. So again, but very similar to Innoslate in that regard. So let's take a look at the Monte Carlo. And again, I'm going to make it light mode for you. And I've got 1,000 iterations set for it. You could put more. Really depends on your, again, remember these are running in the browser. So it really depends on your machine, how many cores you have, things like that, because it is using all the mobile cores and things like that as well. So here's an example of it, and it came up with a 76.8% failure. So again, that could be the procedure, it could be the timing that's been put in for it. Again, that's what the analyst would know and be able to adjust and put in there properly for things. But again, take a look at that and see what you would use this for that kind of analysis. Okay. So I think I've hit the main features of Sopatra. I'm sure there's others that I'm missing, but I think those are the key ones. So we actually did finish before the hour, so we have time for more questions. So Elizabeth, some questions for me?
We do have a couple of questions so far. Our first question is, can you perform roll-ups for any type of attribute that has a value? For example, if you want to assign a mass attribute to your assets, can you now roll up those values to the highest asset in the hierarchy?
Yes. So for example, I think, let's see, look at the chart that has that in it. I think I have a diagram that is, I can show you. Now, by the way, I've not done this yet. There's a hierarchy chart I want. So I have not, oh gosh, that needs to be relayed out. Again, I've not done this, so excuse me. I've not played with this particular one. So again, to show the attributes I want, I would select that attribute. I believe I have one called mass. Just type it mass. Oh, okay. I don't have it in this one. Thought I had mass. Yeah. Mass. Oh, okay. Okay. Sorry, I don't have it. So the answer is yes. You would just go ahead and add that attribute to this, and then you would use that to roll up using the roll up feature and select the attribute you want. Again, I thought I had that in this particular example, but I guess I don't. So.
Thank you, Dr. Dam. I did forget to mention, for all of you that are joining us maybe for the first time, if you haven't done so, there's a panel on your right-hand side that'll say questions. Go ahead and use that panel to ask us your questions. And our next question is, in the Gantt chart, do you get some indication based on task dependencies? For example, task B must follow task A, but task B is concurrent on before task A in the schedule.
I think the answer to that is yes. To be honest, I'm still learning this particular thing, but here's the dependency line between the tasks, and you would select one and then add dependency, and then you would select what it would be dependent on. And so that's how you connect them together. So it's very easy to set that up. And when you do set up, you get to determine whether it's finish to start, start to start, start to finish, or finish to finish.
Thank you, Dr. Dam. Our next question is, can Sopatra's Import Analyzer import an SOP that is in a PDF format?
No, you just convert that to a Word document. If you're not familiar with the Adobe Acrobat, it has a great export to Word, and we highly recommend people use that. It's not something we've tried to crack that code yet on PDF.
Does Sopatra support iteration and conditional steps?
Yes, I'm sorry. Yes, because you can go in Sopatra into this and use any of these conditional items. So I could bring that in here and change the procedure that way easily. So yes, loops, another thing, of course, are here. So we have both those options as well. So you can build a very complex diagram with this. Do not want to do that. Okay.
We have a couple of questions on the availability of both Innoslate 4.5 and Sopatra. When will Innoslate 4.5 be available on Enterprise?
Yeah, that's the 21st is what it's slated to out. That's 2 weeks from the time we released it. That's our standard way of doing that. We want to make sure that the cloud version has been checked out well enough before our enterprise people, because they have to do a fair amount more of installation. And so we want to make sure if there's any bugs that we detect quickly. As it is, we actually already did a sub-point release yesterday because we'd found a number of little things that were kind of annoyances. So we took care of those right away. So we'll be doing that for the next few weeks until we can get enterprise ready to go.
And then when will Sopatra be available?
So Sopatra's scheduled to be released for the cloud on the 14th of this month, and then we'll follow 2 weeks later with the enterprise version.
Great, perfect. So that is all the questions that we have at the moment. If you don't mind, Dr. Dam, let's go ahead and I'll make the announcements for the next webinar coming up.
Okay.
And then we can, if some questions have already come in, we'll come back to the questions.
Okay.
Sometimes a few sneak in when I'm making the next announcement.
Yeah.
Yeah. So we hope you can join us for our next webinar. It's Digital Engineering a Lunar Rover. Our systems engineers have taken the initiative to build a lunar rover using a digital engineering approach and Innoslate. That webinar will be on October 19th at 11 o'clock a.m. Eastern. And of course, a recording and slides will be going out for this webinar as well. So I'm going to come back and check and see if we've gotten any more questions. Okay, what was the top graphic on the California fire slide?
Oh, so I believe that was the, let me see, good spot I think you're talking about. Let's skip out of this. So that was over here, and the diagram. So I believe it was the decomposition of the Gantt chart is what I think you were talking about. And if you're talking about discrete event, I'm assuming, that's our 3D action trace. So what that does is it shows the whole model in 3 dimensions. And let's say as you step through it, it'll step through each step and highlight it, and you can see it go interactively. Now this is, again, one of those things as you get very big, there's only so much space, there's only so many pixels on the screen. And so you can make a model so big that it can't be rendered. And so all you have to do is X out that view, and it'll run fine. So understand that. And that's another thing to do is, as you see if it's too slow or you need to do something else, take a look at what you're putting out there. Do you need all that information? If you do, then it's going to take time. Otherwise, you know, exit out so you don't have to take that extra time. Hopefully that answered the question.
He said thank you. We actually have a couple more coming in. Can you discuss more on the integration between Innoslate and Sopatra?
Yeah, so actually Sopatra runs on top of Innoslate. So it's sort of, we call it powered by Innoslate. And what we did was we hid a lot of the Innoslate features and then also added in new things specifically for Sopatra. So things like tracking the AOTW versus the TOP is something that's special in the code. So there are a number of special things as well. But again, the whole idea was to minimize the amount for the SOP developer so they wouldn't be overwhelmed by all that information else we provide. I'm sure they don't care, the SOP developer doesn't care about the risk chart and cost analysis and all these other things that you put into doing system engineering.
Thank you, Dr. Dam. We have another question. In the Gantt chart, do you get some indication based on task dependencies? For example, sorry, I think I might have read this one. Hold on, this one. For example, you can model the system with expected failure modes, then in simulation, use those failure modes for trigger casualty procedures to correct them. Apologies, they're coming in a little funny today.
Yeah, absolutely. Again, that's part of that, using the decision points in the model. And these decision points. So if I actually modeled in Sopatra this model where I have all these decision points, one of them is actually it's regular operations and others contingency operations. And so that's exactly a failure mode saying there's a problem, I got to go deal with it. And it takes a different time for that purpose. Is all it is in this model. But you might go through, this is it right here, perform contingency operations. If I wanted to detail that, I could decompose it and put more information there. But yes, in many levels, and you can make the model as complex as you want. I've got a very complex one I'm doing for a Navy contract right now that's it's so complex, in fact, I can't render it in here. So
can you demonstrate the Monterey Phoenix integration for formal methods analysis?
I wish I could. I don't have that. So one of the things with Monterey Phoenix is it is focused on the what's it called? It's sequence diagrams. And what we've discovered is there aren't enough sequence diagrams ever, because what we have is a stochastic problem. In other words, it's probabilistic. So that means that I can't assume that I know all the paths. Monterey Phoenix assumes that it can show you all the paths. Just don't think that's possible in a probabilistic thing. So anything with people in the loop have that problem. And that was one of the things as we did the research and looked at it, we decided that wasn't something we were going to try to do for now. Now we'll look at it again. I know Kristen Gianmarco, who's one of the big proponents of the Monterey Phoenix approach. I believe she developed it, invented it, and it has its utility. But it's not really as appropriate for what we're doing, I don't think. So hopefully that answered the question.
Do you plan to have a webinar on Sopatra soon?
Wow, okay, we haven't scheduled anything yet, but at some point, yes, I'm sure we will. And of course, we'll do demos and things like that. It's like we do for everything else.
We will probably have one in November.
November? Okay, cool.
Just to let you know.
What do I know? That's work here.
I think that's all the questions we have today. If you have any other questions, please feel free to reach out to us. We have our support lines available during business hours. You can give them a call, send an email, or you can, I gave it earlier and it's in the slides as well. We have Steve's email there. So feel free just to reach out to us and ask us your questions. And again, the next webinar is going to be on October 19th at 11 o'clock a.m. Eastern, Digital Engineering, a Lunar Rover. We hope you can join us for that. And again, I'd like to thank you for joining us today. And we will be sending out that recording and that presentation slide deck here soon. So thank you again for your attendance, and we hope to see you again at our next webinar.